I already made this video once, but CamStudio, after I had been recording for like half an hour, it just said to me that it is unable to save the file and it deleted everything. So anyway, hello everyone, I'm Joel. I made a Portal 2 video this time, and the point of this video is to explain digital electronics and logic gates. And I'm going to be using the Portal 2 puzzle editor for that purpose, because it was just released a week ago or something like that, and it's a platform under which you can make puzzles which have functionality in them. So I'll just make this little room over here and fill it with some puzzle items. So let's put some button here, and that should be fine. Actually, I think I put a different kind of button. I put this one and two of them, so I can demonstrate a common function in digital electronics. It's a AND gate. Usually when you make a test chamber Portal, I should make little lights here so you can see what's happening. Anyway, when you make a test chamber Portal 2 using this Perpetual Testing Initiative system, it's usually a beginner's problem. I was surprised that when you make a puzzle and you have two buttons connected to an exit like this, when you press one button it doesn't actually open the door. Neither one of the buttons opens the door. You have to press both of them to open the door. And this is a source of confusion for many people, because you would expect that either one of them opens the door, and when you really want to make that either one of them opens the door, you have to make you cannot use the AND gate as was done here. You have to use the OR gate, and here's how to make it. You use this laser relay because the laser relay has this function that you can connect multiple lasers. Multiple lasers can be pointed to it. This is accurate work. Anyway, multiple lasers can be pointed to it, and it reacts to any one of them. So this button here activates that laser, and this button here activates that laser, and either one of them opens that door. And now let's see what happens when we test this chamber. Alright, through some video editing magic we are here. And now I press this button and it opens the door, or I press this button and it opens the door. And as you can see, when I activate the buttons, they both connect to different lasers, but either one of them is enough to activate the laser relay through which the door is opened. Sorry, I have a little flu or something like that here. Alright, so AND and OR are covered. There's a third kind of basic gate that occurs many times in digital electronics or logic, and that one is the NOT gate. NOT means simply inverting the input signal. In a NOT operation, when an input signal is activated, the output signal is not activated, and when the input signal is not activated, the output signal is activated, and that's what is going to happen here. Let's see how it works. Yeah, it's a little slow on my computer. But again, through video editing magic, it becomes a little quicker. Alright, the door is automatically open because the button is not pressed. But when I press the button, the door closes, which means the gate deactivates. The gate deactivates when the input activates, and activates when the input deactivates. And I actually accidentally removed the lights here, so it was a little dark room. So that was and or and not. And let's see what happens when we combine those. Let's make this room a little bigger so we can fit more stuff. So over here I make a little compartment, and over there another compartment, and here a little divider. Oops, this way. And this one glass panel will be showing what happens here. It's our output in a way. Alright, both of these gates that I'm going to be making now require 2 inputs. So here's 2 inputs for both. Alright, the easier one first. On the right side there will be the NAND gate, which is and not in a combination. And in Portal 2 you can make a NAND gate simply by making a NOT gate with multiple inputs. So you have a NOT gate and both buttons are connected to it. Here. Alright, and the other side I will make a NOR gate, which is OR and NOT combined. It looks like I cannot copy rooms in this editor. I can only copy items. Right. They both have to be on the floor because otherwise the relay will not see the lasers. Alright, there's an OR and there's a NOT. And the buttons will be connected to the sides of the OR gate. The OR gate actually can have like 5 different inputs, but for simplicity I will only use 2. It can have any amount, but in the Portal 2 editor you cannot fit more lasers there. And did the light here, because the last room was so dark. Alright. Looks fine, except there's one error. There's one too many lights here. Alright, now it's fine. Yeah, this should be fine. Alright, let's try it. And how does it look? So by default both exits or both outputs are activated because the inputs are not active. That's the not part of it. And on the NAND side you have to activate both inputs in order to deactivate the output. So that's what happens here. If both inputs are activated, then the output was deactivated. And on the NOR side, if either one of the inputs is activated, then the output is deactivated. And when you're making computers, you can actually make a whole computer from nothing but NOR gates, or nothing but NAND gates. They are the fundamental building block of every digital circuit in the world. Well, transistor is actually, but transistor is like a NAND gate. So let's see what happens when we combine many of those NAND gates. Let's put some light here because I actually accidentally deleted the lights again. This is what we need. We need a button, and we need another button, because this machine will have 2 inputs, and there will be 4 NAND gates. Right. And it's called an RS flip-flop. And why it's called that way, it will become obvious very soon. The last 2 NANDs are cross-connected, and the first ones here are actually... No, they are not actually not a NANDs here, they are just NOTs. So this one has 2 NANDs and 2 NOTs. Like so. Time to test it. Yeah. It's initially in an unstable state. It's just the stupid feature of the Portal 2 editor, or the Portal 2 system. So when I press this button, the door opens, and when I press this button, the door closes. And if I press the same button twice, it stays closed. And if I press this button, it opens again. So this system actually remembers which state the machine is in, and that's a memory circuit. Very simple memory circuit. And now with this cube here, I'm going to show what happens if I disable one of the functionalities of it. If I press this button, it seems to work normally, but it doesn't remember the state anymore. And this one doesn't do anything. So now it works again. It's a very resilient circuit. It doesn't break easily. You have to press it. You can even press both of these and it doesn't break. So going on to apply more of these principles. Now let's make let's actually use 4 of these NAND gates now, because this one had 2 NAND gates and 2 NOT gates. So I begin by removing all the connections, so I can reprogram them. So we begin by connecting A to B, and B is connected to the exit. Yeah, I think so. And B is connected also to C. and B is connected to D, and then C is connected to D, and D is connected back to A. And yeah, I have to make this all enabled so they actually are ANDs. I mean NANDs are not ANDs. Input is connected to A and input is connected to C. And that should be it. It's a T flip-flop. What it should do is oops, I have one too many inputs here. I should only have one input. Yeah. All right. So what should happen here is when I press this button, it should open the door, and when I press it again, it should close the door. And it should work like that. It should toggle the state that it was last given. However, when I try this in Portal 2, it doesn't quite work like that. I have no idea why it doesn't really work like that, but you can see what happens now. Seems nice. No. Press it again, and the door closes. Press it again. Oops. What? So it's really quite random here. It's a random number generator or something like that. And it should not be like that. I don't know why it doesn't work in Portal 2, but it just doesn't work. So when I found out that it doesn't work like that, I had to make another solution, and I cannot take credit of this solution because I saw it in YouTube. It's someone else's solution, but it works. Now I'm going to show how it works. So here's the lift, and in the both sides of the lift there are laser beams. And there's an OR gate which is connected to an AND gate, and both of those lasers are connected to the ANDed together and connected to the OR gate. I just make a little decoration here, because this is going to be the final test chamber here. So the button is connected to the OR gate, and the two lasers here are connected to the OR gate on the other side. And the result of the OR gate is connected to the lift, and the lift begins deactivated. So the lift only moves when the OR gate gives it the permission to move. one more thing, I have to make the exit door connected like this. Alright, let's test. Alright. Press this button and the door closes. Press it again and the door opens. Press it one more time and the door closes. It works, and it is really stable. It works. It just works. But it's a shame because the laser circuits couldn't do this. I don't know why. So this is my final example in this series here. Logic gates. So now you know. Thank you for watching. I hope you had fun.